So let's go through and see how we did. So on this triangle, we have a side length of 3. So that means this one's going to be 3. And then 3 squared plus 3 squared equals c squared. 9 plus 9 is equal to c squared. 9 and 9 is 18. And so again, to undo a square, we take the square root of both sides. So let's break it down. 18 breaks down to 9 times 2. And 9 breaks down to 3 times 3, and then the times 2. So what comes out of the radical? The 3's come out of the radical, and the 2 stays in. So my missing side length is 3 times the square root of 2. Okay, so then for the next one. So we have a 5 and a 5. So 5 squared plus 5 squared equals c squared. 25 plus 25 equals c squared. 50 is equal to c squared. And then square root both sides. 50 breaks down into 2 times, or 5 times 10, or 2 times 25. And 25 breaks down into 5 and 5. And so, what comes out of the radical? The 5's come out, leaving me with a 2 on the inside. So my missing side length is 5 times the square root of 2. Maybe we're starting to notice something. So let's take a look at the next one. So our side length here is 6. So 6 squared plus 6 squared is equal to c squared. 36 plus 36 is equal to c squared. 36 and 36 is 72 is equal to c squared. 72 breaks down into 2 and 36. 36 breaks down to 6 times 6. So what comes out of the radical? The 6's come out and the 2 stays in. So I bet you're starting to notice something. Are you starting to notice that my sides are always, of course, going to be the same? My legs are going to be the same, but my hypotenuse. Do you notice a pattern? 2, 2, 2 times the square root of 2. 3, 3, 3 times the square root of 2. 5, 5, 5 times the square root of 2. 6, 6, 6 times the square root of 2. So for this one, I bet you got 7, 7, 7 times the square root of 2. For the next one, you should have got 8, 8, 8 times the square root of 2. 9, 9, 9 times the square root of 2. 10, 10, 10 times the square root of 2. So what would I do if I have a side length of x? Well, by the pattern that we've got going on, how about x, x, and the hypotenuse is always going to be whatever the side length is times the square root of 2. So the last question says, write a general formula for any triangle of this kind. So my legs are always going to be the same measure. Let's call them x. X, x, and the side length that is opposite of the hypotenuse is always going to be x times the square root of 2. What we've just created is a ratio comparing the angles of a triangle to the sides of the triangle. X, x, x times the square root of 2. So we have just come up with a ratio that goes with an isosceles right triangle. When you have a 45, 45, 90, you can always use the ratio x, x, x times the square root of 2.